I'm Stephen Foskett, the organizer of Tech Field Day, and we're here in Santa Clara, California for Tech Field Day, November 2016. If you'd like to learn more about Tech Field Day and what we're doing here, I urge you to come to techfieldday.com. You can find a series of videos just like this at youtube.com/techfieldday. This event brings together a panel of a dozen independent writers and speakers from around the world to meet with interesting enterprise IT technology companies to discuss technologies, to learn about things, to show demos, and to share things with the world. Thanks for watching.
All right, I'm back. Again, just for the benefit of those who just joined, my name is Sai Mukundan. I'm in the product management team at Cohesity. So Mohit earlier in his presentation talked about DataPlatform Cloud Edition, which is something that we are actually going to preview for the first time today. This is the ability to run Cohesity in the cloud. For the purpose of this demo, we are actually looking at Azure, but we also support AWS at this time. And like you heard, there are three use cases that we think that this can really help. One is test dev scenarios, the ability to do test dev in the cloud based on the VMs that have been backed up. The second is DR. Obviously, customers want to leverage the cloud when in the case of a disaster, and then probably other services that the cloud vendors offer, such as analytics, based on the data that has already been moved to the cloud. So there are a lot of moving parts in this demo because we have Azure, we have an on-prem Cohesity cluster, and we have the Cohesity cluster running in the cloud. So the first thing that we will do is create a Cohesity cluster on Azure. So today we are actually in the marketplace. It's in preview mode with some early access customers who are trying this out at this time. So you can see that when we search for Cohesity on the Azure marketplace, the image just pops up. And then when we actually go live with this early half of next year, then the customers can just deploy it on their own. So for the benefit of this demo, we actually are going to look at a cluster that has gone through this deployment, and we will look at what exactly we do in the cloud in order to bring up Cohesity in the cloud. So the thing that we like to call out here is the fact that we are basically using the VMs or the compute resources that are available on Azure. So what I have highlighted here is four VMs. As you heard earlier, we have a 4-node physical block that we sell. So the equivalent of that in the virtual world or in the cloud world is 4 virtual machines, for Azure virtual machines, I should say, running the Cohesity software. Front-ended by a load balancer as well, which is just a standard load balancer available in the cloud. So we can see that this cluster, once it's up, has an associated IP address, and this is something that we will use in the next step in terms of pairing the Cohesity cluster that is now running on Azure with an on-prem cluster. So now that the cluster is up, let's now look at how does this pairing happen. One of the things that you will notice right off the bat is, and when we get to the cloud aspects of our software, is we try to keep the interface and the look and feel absolutely the same, right? So here we have our on-prem cluster, and it's going through the pairing process. So at the very top, you see that the IP address that was provided here in terms of what cluster to pair to was the cloud cluster that we just created on Azure. So now that and then you heard about the concept of view boxes. So every replication pairing is pairing a view box on a source to a view box in another cluster. In this case, it just so happens that the cluster is running in the cloud. But again, the workflow is very similar to what you would do if you were to just pair 2 physical Cohesity clusters. Again, emphasizing the seamless capabilities of how you can use the same Cohesity management software, whether it's in the on-prem world or in the cloud world. So now that we have actually paired this, how do you get data in the cloud, right? So you heard about 3 aspects of how we interact with the cloud. You heard about cloud tier from Mohit, which is around spilling some of the excess data that you don't maybe access as often into the cloud. The second one that you heard was archive, which is mostly for long-term retention, where you leverage, say, an S3 or a Google Cold Line or an Azure Cold. The third aspect is cloud replicate, which is the underlying capability that we are going to use here in order to get the data on the cloud edition of our software. So again, when we have to go through the replication of VMs to the cloud, we start with the on-prem world. The data has to first land on the Cohesity cluster in the on-prem world. So this should be pretty familiar to you now that you have seen a virtual VMware protection as well as physical protection. So in this case, we are looking at selecting a particular VM that we will use to first backup, and then as part of this policy that we create with this VM, we will also set a replication associated with it. And what will happen in this scenario is the replication is going to transfer the data after the backup is completed from the Cohesity cluster on-prem to the cluster in the cloud. So here we have the ability to choose a replication target, and you will notice that the replication target that's been chosen here is the cluster that is running on Azure. Again, you can set the policy, the frequency at which you want the replication to happen, and that is what will determine how often the data transfers from your on-prem world to the cloud world. So in this case, we are just going through the process of completing the steps to create the job and basically run that job after the backup is complete, and that will get the data on the cloud. So there's a question.
You can already store the data on the cloud, and now you're going to spin up a new instance of Cohesity in the cloud and replicate to it. What's the benefit of doing one versus the other?
Sure. So the aspect of storing data in the cloud, which we call cloud archive, is really focused on long-term retention. So you're leveraging, say, like I said, S3 or Glacier in AWS case, or Azure Cool and Cold, or in Google's case, it could be Nearline or Cold Line. The thought process there, or the use case there, is that you want to save this data for maybe a long period of time, but you don't necessarily want to invest on-prem storage resources for it. So there, you're only leveraging the storage aspect of the infrastructure that the cloud provides. The use case that we are trying to address with running a Cohesity in the cloud is more of an active nature, meaning you want to be able to run test dev with it. So we now saw the workflow where we backed up some VMs to our on-prem cluster. Now, let's say I do not want to spin up some test dev in my on-prem infrastructure. I would rather do it in the cloud for whatever reason, right? Or just for the fact that I need something quick and I can deploy it pretty quickly. So then, with this functionality, we replicate the VM to the cloud, and then that's where really the magic happens, right? Because the VMs in the cloud are in VMDK format, and the cloud vendors have their own native formats. Azure, for instance, uses VHDs, Amazon has AMI, and so when we go through the process of what we call the clone to spin up these test dev machines, we also on the back end go through the conversion of these VMs from VMDK to the native cloud formats. So that's what we are going to look at next. So in this case, as you can see in the top right, we have highlighted that it is a cloud cluster. One way to differentiate, which cluster you are on. And I'm taking a VM that has already been replicated into the cloud. And the selection process that I'm going through is determining what Azure resources I'm using. So let me just pause there for a second, because this is pretty important, right? What you see here as the source is the subscription ID associated with your Azure account. The resource group, it's a Azure construct. That's the resource group in which this VM is going to get spun up. Compute, obviously the cloud vendors provide a lot of different compute options. We have tried to abstract it and provide a couple of options for the user. Just keep it relatively simple, small, medium, large. It basically equates to, in this particular case, a DS3 or a DS4 VM on Azure. And then you pick the storage account and the container as well as the virtual network associated with it. So what this is actually doing is it is now taking all the inputs that are needed to be able to spin up a DS3 VM in Azure and bring up that VM that you replicated from your on-prem world. Again, a point to note and emphasize here is the fact that the look and feel and the usability is very similar to the on-prem place, because we don't want customers who have adopted our solution in on-prem world to now go ahead and adopt something completely different. So try and keep it very similar, right? Again, you have the option to choose which snapshot you want to clone from. So as we go through this process, it's on the back end going to now spin up the necessary VM in the cloud and bring up that image. So in this case, I already have an image that was spun up, and if you go and start this VM in your Azure Blob account, then using this IP address that is available in your Azure portal, you can just remote desktop to it, connect to it, and there you have it. Your VM that you backed up is now available in the cloud. So I know we went through a lot, but just let me recap before I take a quick question here. So the first thing that we did, you see in the bottom, is we created a cluster on Azure, and this was using the compute and storage resources available in the cloud, in this case Azure, right? And it was pretty seamless. We could just get into the marketplace and deploy that. The second one was pairing the clusters. We had an on-prem, and we paired it to this Azure cluster. The third aspect that we went through was setting up a job, back up the VM, and replicate it to the cloud world, pretty much. And the fourth step was cloning. And like I said, this is where we take care of the format conversions as well, VMDK to VHD or AMI, as the case may be. And then the last aspect was that you go into a cloud portal and you are able to now access that VM, and you could potentially maybe apply some patches on it, test, go through your scenarios, and then tear it down if you don't need it. So really excited to announce DataPlatform Cloud Edition. I think this also opens up a lot of other possibilities for us. So with that, I want to conclude the session, but before that, I will take a couple of questions right here.
Yeah, one question, just kind of going back to the beginning. Why not, like this seems like a great option, especially for secondary storage, but why not primary storage as well?
Let me just get that clarified. We're talking about, when you say primary storage, are you talking about primary storage in the concept of cloud? Like what exactly are you getting?
Well, in the sense of your day-to-day high access, the stuff that you're using for your critical business functions. At the very beginning, it was put forward that this was mostly for the stuff that you're not needing every day. It's your secondary stuff, but why not on the primary stuff?
Well, I think if you go back to Mohit's vision and the way this company was built from in his mind, he felt that this was an underserved market in terms of just where we are with secondary storage. And if you go back to the iceberg analogy that he laid out, there's a lot of data growth. And couple that with what you specifically saw in the cloud aspect, we also see the kind of use cases that we are hearing both from customers as well as the cloud vendors, right? Whether it's Amazon, Azure, or Google. They're focused on getting a lot of these test dev use cases, possibly provide customers a DR option in the cloud. So it really resonates with them as well that we are going after some of these secondary use cases to help them also get a solid hybrid cloud story. Because with Cohesity, you have a strong on-prem, but now we are enabling you to also leverage the cloud for some of the secondary storage needs.
But is there any reason why this platform would be unsuitable for primary storage?
I think at this time, if we go, again, I want to take you back to what the vision and goal for the company as well as the product is, right? We think that there is a big market to be served in the secondary storage market. So there is plenty to address there for us. Like you saw, today we are still in the data protection area. There is file services, there is test dev, analytics. So I think there is enough for us to bake or fry, as you may call it, and time will tell. But for now, our focus is pretty clear. Stay on secondary storage, deliver the value that we think we can promise. We promise to our customers, and stand behind that.
When you're replicating out to cloud, are you able to take advantage of less expensive storage out there as well? So, for example, going to AWS, and you push stuff off into S3, which costs less, or are you basically running everything on EBS volumes with your layer on the top of that?
So when you look at the cluster that is actively running in the cloud, it's doing a lot of I/O, right? So you need something where you get good read and write access, times. Mm-hmm. The kind of storage that you're talking about, the S3 and Glaciers of the world, are more for long-term retention. But here is where it opens up some interesting possibilities. You could have your cluster running in the cloud, but also leverage the cloud tier and cloud archive to tier within the cloud, leverage those capabilities as well, so that some of your hot data is, like you said, on EBS or the blob storage in Azure, and then tier off or move some of the older data from this cluster running into the cloud into those sort of dormant storage tiers. So those are the possibilities that we are definitely considering, not only from a cost perspective, but I think it's also a great way to optimize performance in terms of keeping what's hot active and then moving it to the colder regions in the cloud.
Thank you.
I've seen examples of moving VMs from on-prem to the cloud where both they do a conversion, but also where they're kind of inserting this another virtualization layer to be able to run, one type of VM in another type of environment. Can you clarify, is it an actual conversion, or are you, shimming one into the other?
So in this case, it's actually it's an actual conversion. So what we did in the Azure example is we basically took a Windows VM that was running on-prem into and spun up an equivalent Windows VM in the cloud. Now, this is probably an area where the cloud vendors are also investing themselves, because as you know, Azure is more further along in the Windows side as it is on the Linux side, and then as they mature and provide more support for various different kinds of Linux images, this sort of migration capabilities also becomes more seamless for us, because we can just leverage those kind of compute resources that they provide to us. So
it's sort of a conversion, but it's actually a new machine.
Absolutely.
Right?
I mean, you're spinning up a new compute that you're leveraging in the cloud, right? Because in this case, we saw a DS3 VM in Azure being spun up. Again, depending on what the use case is, you might choose to spin up a different image, or I guess depending on the VM that was backed up. So that's kind of what the use case is.